body will perform the motion under gravity. And there will be only gravitational force between this body and between the earth. Between this body and between the earth, there is only gravitational force. So this body will perform the motion under gravity.
Yeah.
Gravity, okay. Under gravity, okay, motion under gravity,
Yeah.
or this is also known as free fall. Free fall. So we have discussed that the free fall motion or the motion under gravity is an example of uniformly accelerated motion. So basically, this is the uniformly accelerated motion. Uniformly accelerated motion. Uniformly accelerated motion means acceleration is constant. Acceleration is constant. Constant means, suppose I am saying that acceleration of this body is 10 meters per second square, then during the whole motion, the acceleration of this body will be 10 meters per second square. 10 meters per second square. Okay. So acceleration is constant, and that constant acceleration value for the earth is known as acceleration due to gravity, G.
Yeah.
This is the constant value, and this is known as the constant value of 9.8 meters per second square, and this is known as acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity. Now, I told you there are three equations of motion. There are three equations of motion. And if you will apply the three equations of motion here, first, what is the first equation? V is equal to U plus AT. And this equation of motion is for the uniform acceleration, where acceleration is constant.
Yeah.
A is equal to constant. Acceleration is equal to constant. Second equation of motion is equal to S is equal to UT plus half AT square. Third equation of motion is V square is equal to U square plus 2AS. Okay. So three equations of motion. Now, if you will put A is equal to G, and I told you the direction of acceleration due to gravity is in the downward direction, and downward direction we will take negative, and upward direction we will take positive. That is why this G will be negative. So downward direction we take this is downward direction. We will take positive, and upward direction we will take negative. So that is why this G is negative. So put the value of G in all these equations, you will get the equations of motion. Free fall. So V is equal to first equation. See this first equation. V is equal to U plus, instead of A, you will put minus G. V is equal to U plus, instead of A, you will put minus G into T. This is the first equation of motion.
Yeah.
V is equal to U minus GT. Now, second equation of motion is S is equal to UT plus half in terms of this acceleration, put the value of a, that is minus g. So it is minus g here into t square. Now you will get s is equal to ut minus half gt square. Okay. Another third equation of motion is v square is equal to u square plus 2. Instead of a, you will put minus g multiplied by s. We will get v square is equal to u square minus 2gs. So these are the equations of motion for the free fall. These are the equations of motion for the free fall. Now another question. They are saying a train travels from one station to the another at an average speed of 40 km per hour and returns back to the first station at an average speed of 60 km per hour. Find the average speed and the average velocity of the train. Ignore the stopping time at the second station. Okay, they are saying ignoring the stopping time at the second station. Means there is a train. Okay, there is a train. I'm just showing the train with like this. This is a train, a point object I'm saying, showing. This train is going like this and moving with a, suppose this is a station 1 and this is the station number 2. So the train is moving from station 1 from 1 to 2, and during this motion in this direction, when the train is moving in this direction, the average speed, okay, 40 km per hour. It's 40 km per hour. On returning, the average speed is 60 km per hour. On returning, the average speed is 60 km per hour. We have to find the average speed during the whole journey. During the whole journey, we have to find the average speed. Now, what is the average speed? We know. Can you tell me the formula of average speed? I told you many times.
Total distance over total velocity.
No. Total time. Total distance.
Time.
Total distance divided by
total time.
Total time. So how we will calculate when we do not have the total distance and neither we have the total time. So how we will calculate the total distance? Total distance, you can say this train is going from one station to two station. The distance between station 1 and station 2 is suppose any distance d. So d is the distance between the two stations. So when the train is moving from one station to another station, this train is covering the distance of d. And when the train is returning from station 2 to the 1, then how much distance will it cover?
Same distance.
Same distance. Very good. Same distance. Yeah. So what will be the total distance of the whole journey? D. And
D plus D.
This is going D, and this is coming D plus D, 2D.
Yeah.
D plus D, 2D, and divided by the total time. So how we will calculate the total time? Suppose total time is T. So total time is time in going from station 1 to station 2 and time in returning from station 2 to the station 1. So you can write time of going from one station to second station Second, this is a station.
Hmm.
This is first station. First station to second station. Time is time of going from one station to another station. We know that speed is equal to distance upon time. Speed is equal to distance upon time. Distance upon time. From here we can
Yeah.
find the time.
Yeah.
That is equal to distance by speed.
Hmm.
Distance by speed. So now suppose T1 is the time in going from station 1 to station 2. So T1, what is the distance the train is covering in going from one station to the another? That is D. That is equal to D. That is equal to D. And with what speed the train is moving? With 40 km per hour. With 40 km per hour. D by 40. So D is also in kilometer. Okay. Now
Yeah.
time of coming from second station to one station. This is the time of returning. This is the time of returning. You can see this is a returning time. Returning time. Returning time is T2. So returning time T2 can be given by the returning distance. What is the returning distance? That is D, and returning speed is 60. So D by 60. It will be D by 60. Now, what is the total time of the journey? We have assumed T, then that is equal to time of returning, time of going from station 1 to 2, and time of returning from station 2 to 1. So it will be T1 plus T2. What is T1? T1 is D by 40 and T2 is D by 60. Okay, so put the value of time here. In this equation, average speed is, we have the average speed, that is D plus D divided by T. So average speed is equal to D plus D means 2D divided by T is total time is this D by 40 plus D by 60.
Yeah.
D by 40 plus D by 60. So now this is 2D. Now from here you can take D common. So it will be 1 by 40 plus it will be 1 by 60. And this D and D will be cancelled out. Now you can take the LCM of Rayyan, can you solve this expression? Try this expression by yourself.
Okay.
Then I will discuss.
Okay. So will it be 2 over 120?
I'm checking.
Hmm.
So this is equal to 2 and this is divided by, here the LCM will be 120. So it will be 4 3s are 3 plus 2. So basically
Yeah,
it
sorry.
will be 2 over 5 over 120. So this 120 will be in the numerator and here will be the 5. So when you will cancel out this with 5, so it will become 5 to the 10, 5 for the, it will become 48 kilometer per hour. 48 kilometer per hour will be the average speed. Now you can see how we have calculated the average speed, because here there is only one thing given, only the average speed is given. Nothing the distance, but the equal distance is given. So that is why we are able to calculate here the average speed. Okay. Otherwise, it is very difficult. So please write down all the things properly.
Okay, sir. Okay, sir, I wrote this down. Okay, sir, I wrote this down. Okay, sir, I wrote this down. Okay, sir, I wrote it down.
Okay. Understood now how to calculate the average speed in this case?
Yeah. Sir, after this question, I need to join a maths tuition. Is it possible?
Okay, so we
Yeah.
will do this question. Basically, this is a true
Yeah.
false question. Okay, so first read the question. They are saying a body moves with retardation when it is projected vertically upward. Is it true or false? Retardation means the negative acceleration, you can say.
It's false.
Okay, we will see. Answer number 1. This is the ground,
Yeah.
and from the ground, you are projecting a body in this direction.
Hmm.
So the body when move upward direction, so at some point, the velocity of the body will become 0,
Oh,
and
yeah.
here will be some initial velocity.
Yeah.
Velocity is increasing or velocity is decreasing? Velocity is decreasing here.
Yeah.
So if the velocity decreasing, then what can you say? But why the velocity decreasing? Because acceleration due to gravity is in this direction. That is why
Hmm.
here the acceleration is in the opposite direction of the velocity. Okay, so that is why
Okay.
the velocity is decreasing. And what is the meaning of the velocity decreasing? Means there is a retardation.
Hmm. Okay.
Wherever there is a retardation, means velocity will decrease.
Yeah. Okay.
And whenever there is an acceleration, there will be in velocity will increase. And this is true.
Yeah.
Means.
Hmm.
Second part, a body is projected vertically up. On reaching the maximum height, its velocity becomes 0 or not?
Yeah.
Yeah. This is true or false? True.
It's true. Yes.
Fine. It is true. You can see here, na?
Yeah.
When you are showing the body here in the last classes, we have done one experiment also. I have just shown one pen, and I told you at some point with maximum height from the ground, the velocity